Hello everyone and welcome. My name is Dr. Maziar Hosseini. I am a PhD graduate from the Department of Architecture at the University of Strathclyde based in Glasgow. Today I'm going to present a paper based on the topic of my PhD research, which is about fault-factory technology and its applications in architecture. Here I would like to begin my presentation with a brief exploration in the history of mass production and the flourishment of international style in architecture. Prefabrication is regarded as an industrial process which in the mid-20th century became linked with the mass production movement of the post-World War II time. The destruction of the cities had resulted in a high demand for buildings which could be built rapidly. The war had caused a deep economic decline, and additionally, the construction industry was struggling with the shortage of material and resources. So the construction industry had to concentrate mostly on functions of the buildings and drop anything considered to be ornamental. The less flexible production factories of that time were incapable of delivering high production volume and also customize their products at the same time. So as a result, buildings became homogeneous, damaging the local culture and neglecting individual needs while degrading the surrounding environment by the excessive use of the natural resources. In the early 80s, a group of theorists presented the critical regionalism theory that addressed the negative impacts of globalization, fading local identities, and neglecting the vernacular factors in building construction. The theory included mass customization and introduced this as a way out of these troubles and nominated the digital technology to offer creativity, customization, variety, and also to deliver economy to the projects. Digital design, process planning, and digital manufacturing were initially introduced as totally separate and individual processes and have been used in production projects for many years now. But these separate stages done by separate teams could cause a lot of troubles in a project. For example, they could have designs which couldn't be built since they weren't matching the production line capabilities. Also, goods could have been manufactured not fully compatible with the initial design specifications. So a fully integrated digital design and manufacturing system emerged, which is commonly known as file to factory. Uh, in a in a file to factory based system, robotic manufacturing machines can add an extra level of flexibility to the production line since they don't need much setting up and they are capable of producing a large variety of products. So customization could be more achievable in projects. Digital architecture could also benefit from production strategies such as concurrent engineering and lean production, which are imported from other industries and modified to suit construction sector. Concurrent engineering basically encourages the different stages of projects to develop simultaneously and at the same time. The advantages of it could be named as time saving, efficiency, fast response to demands, and reduction of costs. But one of the major risks of this strategy is that throughout different stages of the project, major changes can happen, for example, in the product design process. In a concurrent system, as a result of this change, Major parts of other processes, such as production planning and manufacturing, that happen concurrent to the design process may need to be largely modified or even redone. A fully integrated digital system can offer capabilities to rectify these flaws. For example, in this system, when designing a product, there are many other processes in progress in the background. Things like the formation of bills of material, structural calculations, ecological impacts, energy consumption, cost, production planning, and many others are being done automatically, concurrently, and almost instantly while the design is in progress. Um, this factor eliminates the labor, time, and cost-intensive process of redesign or rework. Um, as a next strategy, we have the family of lean production that set rules to eliminate waste, increase productivity, and efficiency by minimizing the non-value added activities throughout the project. Lean production rejects relocation of material, goods, machinery, and staff, prohibits material storage and buffering the goods. Since setup time is not considered a value-adding activity in a production line, it should be reduced as much as possible. Overprocessing in any stage of project, any imbalance between production volume, quality, and the market demand is also regarded as waste and against the rules, so must be removed from the projects. Now, let's talk about the case studies which have been analyzed in this research. First, we have Frank Gehry as one of the first architects who has applied integrated digital design and manufacturing systems in his projects. He used them mostly to gain maximum creativity and uniqueness in his design and his creations. Today, he's considered to play in his own league by benefiting from the most advanced technologies and the most expensive equipment and staff. All of these costs and a complicated system make his system mostly unaffordable and inaccessible for the majority of the population. Um, In contrast with Gary, there are groups like Winson Company who concentrate on pure productivity of the process. They claim to mass produce 10 3D printed buildings in a single day by using recycled construction waste material. Their approach could work very well in many aspects, yet from customization and regional architecture point of view, it may cause adverse impacts on the built environment, similar to what happened during the mass production era. Nowadays, apart from the technical and technological improvement of construction, democratization of the technology and the architectural products play a key role in improvement of the built environment. Um, Companies like Facet Homes, which have been studied in this project, are stepping in this direction. They have created and supplied a file-to-factory based system and use them in their projects to design and construct customized buildings that are compatible with the demands of their clients and the environmental aspects of the project site. In their projects, the design process begins like the most of other architectural projects, and this is by gathering information from the client and the project site and creating a design plan. The result is a highly customized and unique design matching the project's exclusive design plan. In the next stage, their patented method called deep process takes action. The transition from design to construction by creation of a precise 3D digital model is one of the most important elements of their process. The model contains all the necessary technical data. Uh, we know that the modularity is one of the main factors allowing mass customization of projects. This team uses modular system in their projects, and dimensions and shapes of the modules enable them to be extremely flexible and creative with the buildings that they design and build. Calculation of the module shape and sizes are determined through an automated computerized process, which means that they are utilizing the advantages of the concurrent engineering, since procedures such as this possibly can be finalized concurrently and very rapidly. After the preparation of foundation, which is mostly a manual process, raw material and a container sheltering the fabrication facilities are delivered to the site. According to the parametric model of components, a flat pack of each module is automatically cut out of the plywood sheet using a CNC router. The parts are then assembled, requiring a minimum manual skill set. According to a digital plan and part IDs, the assembled modules are manually put together using only a hammer. The module sizes are calculated in a way so they could be manhandled using minimum labor and tools on site. And just like these, the building is ready for the finishing processes, which are done mostly manually. And in the end, in order to summarize this presentation, I would like to say that the time has proven that the globally homogeneous built environment has had adverse impact over the societies and the environment. In response, the critical regionalism has offered mass customization as a way to fight these impacts. The theory suggests the use of digital technology to help us to be capable of creating unique products and delivering economy within projects. Any production technology, as it's been described in the presentation, should be accompanied by appropriate strategies to help it hitting the project targets. An example of the use of digital technologies and production strategies are found in the workflow of the Facet Homes company. Their work is a flexible mixture of traditional method of design and the most advanced digital capabilities. And in a brief, by using optimized and flexible production methods, Facet Homes has designed and built regionalized, customized, unique, creatively designed, efficient, less complicated, faster built, less expensive buildings compared to the more traditional industrial methods. And in the end, considering all of these factors, they have managed to democratize the process and their products so they could be affordable and accessible for a bigger group of people while trying to deliver all of these qualities in their products. In the end, I would like to thank you for your time, and I hope that you use this presentation. Have a good day.